All right, so jumping into some examples. These ones, it's just like one chunk of problems, and then we'll jump down to some area problems. But like I said, these only produce one triangle, so there's nothing super crazy that we have to do with these. And again, if we want to, we can just round to the nearest whole number. I'm not going to round the numbers that they're giving me, but if I want to round my answer to the nearest whole number, that's fine. If you're like, I'm fine with decimals and I'm just going to leave it, that's also fine. I don't care. But number 20, angle C is 28.3 degrees. Side B is 5.71. And again, they're putting units on this if I'm not doing the units. And A is 4.21. So the distinguishing feature for you to know that this is a law of cosines problem versus a law of sines, because I mentioned this last week, but on the quiz and the test, I'm not going to say use the law of cosines to solve this problem. All it's going to say is solve the triangle. So you're going to have to determine which situation that we have. So in this case, I have two side lengths and an angle that doesn't go with either of them. So that has to be side angle side. So this has to be the side angle side case, which automatically tells me that I am using the law of cosines. Okay. Also, if you're given all three sides, the only option is law of cosines. And so those are going to be your distinguishing features of these things. Anyways, so I like to go ahead and set up, all the things that I'm solving for just so that I have it and I can make sure that I've got what I need. So 28.3, got 4.21, and 5.71. So based on the given information and what my formulas for law of cosines say, the only thing that I can solve for right now is side C. Okay, so I'll write it out. C squared equals A squared plus B squared minus 2AB cosine C. Now, you don't have to write the formula out as like letters every time. A lot of times I'll go straight to plugging in numbers, but since this is, we're just getting used to it. So a lot of times too, to save a step, I'll go ahead and take the square root and just like write everything under it when I'm solving it. So I've got 4.21 squared plus 5.71 squared minus 2 times 4.21 times 5.71 times the cosine of 28.3. So the other thing that I'm going to point out, I'm going to show you when I go to type this in, just because this is the point where people will often get stuff wrong because they type it in wrong. So when I go to type this in, try to put it there, I have the square root, and then this square root will just keep expanding as long as I'm typing under it. So everything here is under that square root. So I use parentheses on everything when I'm doing this, so it looks just like it's written on my paper. So 4.21 squared plus 5.71 squared. Now, it's minus all of this. So I would do one big parentheses. So basically, I would put one here, and then I can't see the end of it. There we go. And then one there. So that way, all of that's being subtracted off. So that you don't risk missing something here. And it's minus all of that. We don't want it to just think it's minus 2 times something. And so that's why I do it that way. So anyway, so I've got minus parentheses 2 times 4.21 times 5.71 times the cosine of 28.3. And then I'm closing my big parentheses there at the end. And so then I get 9.91. I'm just going to round that to call it 10. That does not make, that's not going to make sense. What is that? What just happened? Did I type something in wrong? That number does not make sense. Hold on, I don't know what's happening.
Are you Reagan's mode?
Thank you. Yep, I certainly was. Okay, there we go. You would think by this point I would remember to check that. However, going back and forth between classes doing different things, don't always remember that. Good call. Yes, it is. Okay, I literally just I went up and I hit enter and it brought it down. So 2.8, so I'm just going to call that 3. So C equals 3. But you'll notice, the reason that I knew that didn't make sense was because angle C produced something that was large, and there's no way that my other two angles can both be smaller than 28 and my entire triangle add up to 180. So I knew something was wrong. Which is what flagged it, me to figure that out. So, anyways, when I finally got to typing in the cosine of 28.3, I would have realized that it should have been somewhere in the order of 0.8, and it would not have been equal to that because I was in radian mode. So, anyways, now, at this point, I'm going to switch to using the formula for law of sines. That doesn't mean I'm going back and determining how many triangles or anything like that. All I'm doing is using that formula to solve for the other angles because it's easier. Okay, so I'm going to work my way. I'm going to start with angle B because it's bigger than angle A, even though obviously this ends up being a smaller one. But I'm going to start with angle B here. It's focused. So I've got the sine of B over 5.71 is equal to the sine of 28.3 over 3. So I end up with B is equal to, write this. This is going to be the inverse sine, ultimately, of 5.71 times the sine of 28.3 divided by 3. And that gives me an angle of 64 point, oh, I'm not doing that. We'll just call it 64 degrees. And so then angle A, obviously I can just do my 180 minus the other two, so minus 28.3 minus 64. And so I get an angle of 87.7 degrees. Now, what do we notice?
The angle for A is too big for the sine.
Yeah. So when that happens, nothing mathematically that I have done is wrong. Okay? Because obviously it's fine. But obviously we're noticing something's not right. So when this happens, I would just make a note and I would say that the angles and sides don't match up, and say that angle B should be larger than angle A. And at that point, then I would just leave it at that. Mathematically, nothing is wrong. It's just the order that we did it in. If I went through, we can look at it. If I did the sine of A, or over 4.21, is equal to the sine of 28.3 over 3. And I do it solving for a instead of b. We'll just see what happens. Maybe in this case this one will work better. So a is equal to the inverse sine of 4.21 times the sine of 28.3 over 3. I get that angle A is 42 degrees. Pretty drastic difference, right? So if I do that, then angle B would be 180 minus 42 minus 28.3. And I would get that angle B is 109.7 degrees. So it's all about the order that we do it in. In this case, technically, these would be the right numbers. Really, would be 42 degrees, and then that one would be 109.7. Because that would make them make sense. But my whole point of this is, yes, I can sit here in an example and I can do it, but I don't want y'all to waste time going back and redoing it. Just tell me this doesn't make sense and move on to the next problem. If you want to go back and change it or try it, I'm never going to stop you, but just know that when that happens, that's why it's all about the order that we do it in. Typically, I do the larger first and it comes out right. This one obviously did not. Why? I still don't understand. As long as I've been teaching it, it does not make sense to me. Because it's one of those things that I feel like if it really matters, they should be putting it in the books, and they're not, as to the order. So, anyways. Onward and upward to the next problem. (24) side length A is 28, side length B is 47, and side length C is 58. So obviously, which case do I have here?
Side.
Yep, side. That's the easiest one to distinguish what it is, because obviously you're not given anything else. So that means I'm going to have to solve for an angle. Let me just go back and look and see. I really don't want to do this whole triangle and it be like, backwards. Find the largest angle using the law of cosines. Okay, this is interesting. On page 763, they say, if you're given side angle side, which was this one that we were just given, it says find the third side. I've never seen a book write this out before. That's why I went back to look. Find the third side using the law of cosines. That's what we did. Then it says find the smaller of the two remaining angles. So that means we should have used what's written in green. Okay, because that means that we should have done A first and then B last. So it's the smaller one first. But in side, they say find the largest angle using the law of cosines. So that means that we should be finding angle C first when it's side. And then it says to find either of the other ones. It does not matter which one. So if it's side angle side, I'm going to go back up here and add this. I'm just going to go up here. So if it's side angle side, find the side then the smallest remaining angle. If it's side, 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 find the largest angle first. So interesting. I've never had a book do that before. But I went back, I was like, let me just see. And again, that info is on page 763 if you want to go back. Very interesting.
So for side equal side, how do you know like which is the smallest?
The smallest side should have the smallest angle. So that's why I said when I did this, typically, anything that the book has said, it's always said find the biggest one first. That's why we went with finding angle B first initially. But then those didn't make sense because this is 5.71 bigger than 4.21, but yet that angle ended up being bigger. But what this book is saying, which is interesting, is that if it's side angle side, we should find the smallest remaining angle first, then the biggest one, or whatever's the next one. But with side, 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 we should start out with what should be the biggest. And so with that, the biggest side happens to be C here, meaning I should be solving for angle C. So, learn something new every day. I still don't know. It still is hypothetically possible something could happen. And like I said, again, if you recognize, if you're like, man, I did all this work and it doesn't make sense, just write the note. It's fine. Do not go back and redo it. I'm not that worried about it. I'm looking that you know the process and then that you're recognizing, hey, this triangle doesn't make sense, right? That's really the only thing I'm looking for here. This is just like a very basic intro to this stuff for solving. So that being said, I'm actually just going to write this stuff here so we'll just fill in the, why did I just do angle C? So we'll just go back and I'll just write underneath that in a minute. And you'll notice because these are all just one triangle, I'm usually not even drawing the triangle because I don't really need to with Law of Cosines. With Law of Sines I did because I needed to determine which case I had. And then with side angle, obviously I need to determine how many triangles I have. But when it's Law of Cosines, I don't usually end up drawing the triangle because it's always just one. But if you want to draw it, be my guest. So that means I need to solve for angle C first. So I'm going to do, I'm using that manipulated formula. So angle C is equal to the inverse cosine of C squared. I'm just going to go ahead and write it out. Minus A squared minus B squared over negative 2AB. So then I'm going to go through and plug everything in. So I've got the inverse cosine of 58 squared minus 28 squared minus 47 squared over negative 2 times 28 times 47. So again, typing this in, I want to be really careful. A lot of times what I do is I'll actually solve the fraction first, then I'll put it into the inverse. So I think I've talked about this before, but if I want to do a fraction bar, I can do alpha y equals, and it'll bring up a fraction bar for me so that I can type this stuff in. So it'll be 58 squared minus 28 squared minus 47 squared, and then on the bottom, negative 2 times 28 times 47. And notice it's currently giving it to me as a fraction still, which is fine, obviously. So now then I hit second cosine, which gives me my inverse cosine. And if I want to use this answer, I don't have to type this in myself. I can hit second and the negative sign, which is at the bottom under the 3. And you'll notice it says answer. That's the most recent answer in your calculator. and it will take the inverse of that, and so that tells me that that angle is 98 degrees. So angle C is 98 degrees. Now, ultimately, they say with side, then I can choose any of the angles to solve for. I would just keep working down biggest, going down as far as this goes. It shouldn't really make that much of a difference. We're just going to go with it. So I'm going to solve for angle B. I'm going to switch over and use the formula for law of sines. It's easier. If you want to continue using law of cosines formula, again, you can, but it's harder formula. So I'm going to do the sine of B over 47 equals the sine of 98 over 58. So B is the inverse sine of 47 sine of 98 over the sine of, or not sine, over 58. So type that in. I get $53 degrees. So far, so good. And then angle A is just 180 minus 53 minus 98. And so that gives me an angle A of 29 degrees. And that makes sense. Smallest angle and smallest side go together and so on and so forth all the way up. So this would be my triangle solved out here. Any questions on that one? Let's see. 32. Angle C is 59.7 degrees. Side A is 3.73 and side B is 4.70. So I'm going to set this up. So I've got to solve for side C first. It's the only thing I can solve for. So I've got C equals, the square root of 3.73 squared plus 4.7 squared minus 2 times 3.73 times 4.7 times the cosine of 59.7 so then type this all in. And I get a side C of 4 point, not 4 point, we're just going to call it 4. So then side angle side, I'm going to solve for the smaller angle. So which one would that be? Yep, angle A. So sine of A over 3.73 equals the sine of 59.7 over 4. So A equals the inverse sine of 3.73 sine of 59.7 over 4. I'm not typing this in right. Come on. And that gives me 53 point, nope, not point, we're 54 rounded. So 54 degrees. So that means angle B should end up being the biggest one. So we've got 180 minus 59.7 minus 54. And that is 66.3. So that makes sense there for that. So I'm going to stop there for today. I'll do one more probably example tomorrow, just as a refresher, and then some, like probably 2 or 3 area problems. Area is pretty easy. And then y'all will have time to work on this stuff after that. If you didn't put your 8.1 homework in the box, make sure you remember to do that as well.